Ever pondered about the parameters that define the performance of an instrument? Imagine a game of archery, a bullseye, and an arrow. Let's dive in to explore the key parameters using this analogy. Think of accuracy as the ability to hit the bullseye consistently. If you're consistently hitting the center of the bullseye, you're accurate. Sensitivity, on the other hand, is how responsive the system is to slight adjustments. If a minor change in your aim results in a noticeable shift in the arrow's position on the target, that's high sensitivity. Now, precision is all about consistency. If the arrow repeatedly hits the same spot on the target, it indicates high precision. Next, consider the span. In our scenario, it would be the diameter of the bullseye, the difference between the minimum and maximum values that can be measured. Range is the difference between the lowest and highest values that can be measured accurately. Picture the distance from the outermost ring to the center of the bullseye. Reproducibility measures consistency of results under the same conditions. If different archers using the same arrow consistently hit the same spot, that's reproducibility. Offset is the gap between the measured value and the true value when the input is 0. Imagine aiming at the center and measuring the distance between the center of the bullseye and where the arrow hits. Drift is the change in output over time when the input remains constant. If the arrow consistently hits a different spot on the target over time, there's drift. Hysteresis is the difference in instrument readings for the same input, depending on whether the input is increasing or decreasing. It could be the difference in arrow positions when moving towards the center versus away from it. Resolution is the smallest change in the measured variable detectable by the instrument. In our game of archery, this would be the smallest noticeable change in the arrow's position on the target. Repeatability is the instrument's ability to provide the same output for repeated identical inputs. If shooting the arrow at the same target multiple times consistently yields the same result, it's repeatable. Lastly, linearity measures how well the instrument's response corresponds to changes in the input. If the arrow consistently moves a certain distance on the target for a given adjustment, it demonstrates linearity. In conclusion, next time you see an arrow fly and hit a bullseye, remember it's not just a game. It's a perfect analogy to understand the intricate parameters that define the performance of an instrument.